Today in Building Services Module 1 we are going to see about the generator. Generator is a device which converts the mechanical energy into electrical energy which we can use for the electrical circuits. So the main source of mechanical energy will be from the steam turbines, gas turbines, water turbines or internal combustion engines and even the hand cranks. So these generators will be of two types. One is DC dynamo type and AC alternator types. So this actually works in the three stages. So first stage, that is during the starting stage, battery supply all the load currents, and in the second stage, that is normal operation, generator supplies all the currents and recharges the battery, and during the third stage, that is peak operation, battery helps generator to supply the current. This generator mainly works based upon the Faraday's law of electromagnetic induction. So Faraday's law of electromagnetic induction is nothing but predicting how a magnetic field will interact with an electric circuit to produce an electromotive force. This phenomenon is called as the electromagnetic induction. So this is the fundamental principle of working of the transformers, inductors and many types of electrical motors, generators and also the solenoids. So it also Fleming right hand rule. So that is forefinger, middle finger and the thumb finger are held in the mutually perpendicular direction, whereas the forefinger indicates the direction of the magnetic field and the middle finger indicates the direction of the current and the thumb finger indicates the direction of the force. So the generator which produces the direct current is called as the dynamo type generator, which is the DC generator. So if the conductor cuts magnetic lines of force, electromagnetic force is generated in the conductor, and that the electromagnetic force produced will vary with the number of magnetic lines of force, the number of conductors, that is number of coil windings, and the speed at which the conductor cuts the lines of the magnetic field, then produces the current is collected by using the external circuit. So if a conductor is turned clockwise, that is in between the north pole and south pole of the magnet, if the conductor is placed and it is turned clockwise, so the electromagnetic force will be generated in the direction where the arrow points out. So this is the Fleming's which works under the Fleming's right hand rule. So construction of the DC generator, it mainly consists of the pole cores, field coils, armature, brushes, pulley and the frame. Pole core is nothing but the north and south pole of the magnet when the current flows through the field coils. Then field coil, so it is an insulated wire wound in the coil form and installed around the pole core. The current flows through the field coil. An armature, it is the shaft rotates inside the pole core and produce the electromotive force. It is compressed of the rotating shaft with the armature coil at the center and the commutator at one end. So the commutator serves to convert the AC to DC. Next, the brushes is to pass the current generated in the armature to the field coil and to the outside of the generator. It is mainly made up of the carbon. And to cool the generator, that is a fan arrangement is kept, which is known as the pulley. Next is about the characteristics of the DC generator. That is, so high speed operation will cause high current to flow through the battery. Battery and the generator and other circuits and shorten their service life. On other hand, during the low speed, only small current will flow. So to prevent this condition, the regulator is provided. So the control unit, that is regulator, consists of the three relays. One is the voltage regulator and the current limiter and the cutoff relays. Voltage regulator is to control the generator voltage and the current limiter is to control the output current, and cutoff relay is to prevent reverse flow of the current from the battery. Next is about the alternator type AC generator. So the increasing number of accessories also consume a large amount of power. We need to generate more power, but DC generator capacity is only limited to overcome this problem. So alternator type is used. Alternator is the heart of the vehicle electrical systems. When the engine is running, it uses the electromagnetism to change some of the engine's mechanical energy into the electrical energy. It is of two types. One is conventional and the separate voltage regulator type. Mostly regulator, that is inbuilt regulator alternator generator is used. So the ampere is ranging from 80 to 40 to 80. So next is about the construction of the AC generator. So it consists mainly of the stator, rotor, brackets and brushes. Stator is the three set of armature coils and rotor is the pole. Rotor is of two types. One is the pole type and the Randall type. Mainly the Randall type is used. In this type, the number of poles is equal to the number of finers. Then bracket. So the end bracket opposite to the pulley side has 6 diodes assembled into it that serves to rectify all of the three-phase AC generated, and also brushes to serve to pass a current of 2 to 3 amperes to the rotor coils. In alternators, the main current does not flow through these brushes. Next is a rectifier, that is alternator produces three-phase AC, but the automobile charging system needs DC supply. So converting AC to DC is called as the rectification. Rectification can be done in several ways by efficient way in using diodes. Next is about the working of the AC type generator. There is alternator type generator. So it is designed to change the mechanical energy into the electrical energy. It works under the principle of the electromagnetic induction. When the rotor spin, it's a strong magnetic field cut across the stator winding. So this induces the current in the stator winding. If the stator winding are connected to a load, the load would operate. So this is again, that is when it is kept in the magnetic field, the conductor is kept between the north and south pole. When it is rotated in the clockwise direction, the current will flow in the direction where the arrow points out in the figure. These are the advantages. So the rotor has high strength against speed and good rectifying characteristics. Current limiter not required depending on the design. Cutoff relay is not required. Charging is possible while idling.